for a minute. What's going to be the same? The denominator, okay? So you won't change the denominator. You're just going to think about, okay, well, this one's too easy to think about that. Let's write that one down. Let's do the next one, okay? You're just going to think about what would 1 whole be if it were a fraction? What would it be? 5/5. So 4 plus what equals 5? 1, okay? So 1 plus what equals 7?
6.
Okay, you want to try the ones at the bottom?
Yes.
Okay. That's pretty simple. So, Oziel, what'd you get on this one?
I know, 5 9.
Very good. Lila, what'd you get on this one? And someone in block 1 said, do I need to simplify that? Not for making 1 whole. But aren't you tempted? Don't you want to divide by something to make it smaller? What do you want to divide by? 2. Okay, Sergio, what'd you get here? 3. And I bet we could divide that one too and make it smaller. Okay, so let's look at the next one. These are very similar. Okay, we're making 2, but they gave us 1. So that's cool, isn't it? Okay, so it's the same exact thing. I just have to make 1 whole. You want to try these and then I'll pull sticks?
Yeah.
Are you already done? Okay. Jesus, are you done? Okay. Ryder. Well, Ryder, what'd you get on this second one? Good. Adam.
1/3.
Good. Eileen. Good. And Tyler. Very good. Okay, next page, or next slide, not so easy. Oh, that's funny. Okay, so these are a little different. Now I notice that all these denominators are 2, all these denominators are 3, and all these denominators are 4, and they're going to keep getting larger. I want to start with the highest number. Trust me. Over here, I want everyone to write 11 divided by 2 because this is a strategy you can use when the numerator is a lot more than the denominator. Okay? So 2 times something is close to 11. 2 times 5. Where'd you write the 5? The last digit. Okay. And do you remember the strategy? It's even on the anchor chart. It says you can take the remainder, put it on top of the divisor, and make a fraction. So the answer to this is 5.5. Okay? And when your numerator is a lot more than your denominator, that's a strategy you can use. But how many of you can do 2 times 5 equals 10 in your head and then just know it's just 1 more? All of you. Okay? So let's try and do this one in our head. We're going to do the same thing as the long division, but we're going to do it in our heads. So 2 times something is close to 7. 3. And that would be 6, right? So write the 3 down because that's what I would put on top. And so that's going to give me 6 halves. Just thinking about it in my mind. Okay? What's 6 halves or 7 halves minus 6 halves?
1 half.
Or just a half. Okay, let's try this in our heads. 2 times something is close to 5. 2 times 2, what is it?
4.
Okay, 5 minus 4. And did you notice my denominator didn't change? It's 2 every time. So technically, I could put the 2 down before I ever start. Okay, 2 times something is close to 3. 1. So 2 times 1 is 2, right? Plus how many more to make 3? Okay, so this time we're going to go easy to hard. But do you see what I'm writing there? Okay. So 3 times what equals 4? Nothing, right? 3 times 1 equals 3. 4 minus 3 is
1.
3 times 1 equals 3. 5 minus 3 equals 3 times equals 9. 10 minus 9 equals, oh, this one's tricky. 3 times 7. Because 3 times 8 is 24, and that's too big. So 3 times 7. I'm going to write this down. Watch it. So 3 times 7 is 21. And then there's 1/3 left over. So 7 and 1/3. How many of you think you can try the last row by yourself? Worst case scenario, if you're confused, do long division. All of you know how to do long division. I'm going to pause it while you're working on these. So let's take a look at 5/4. Hey, Jesus, what did you get for 5/4?
1.
And
1/4.
good. So Cody, what about 7/4?
1 3/4.
Very good. 11/4, Alan. Let's look at 11 divided by 4. Okay. 4 times what? 2.
2 3/4.
So, Alan, did you write this down? I was talking to Alan. So 2 is my whole number, and my remainder is the numerator. Yes. Okay. Now, how many of you hope I'm going to pull your stick on this one? I know. Isaac, you're the winner. What'd you get?
9 3/4.
You guys agree?
Yeah.
Yeah. Okay. So I'm going to pause it. You better get going. So let's look at the application problem. This makes me hungry for lasagna or pizza or something. The Napoli family, doesn't that sound Italian? The Napoli family combined 2 bags of dry cat food in a plastic container. One bag had 5/6 kilograms of cat food. The other bag had 3/4 kilograms of cat food. What was the total weight of the container after the bags were combined? We've got a couple words here that are going to tell us what we're going to do. Total is one of them. What's the other? Combined. Okay, so what am I going to do? Addition. So I'm going to do 5/6 plus 3/4 equals. Do you want to solve this with method 2 from yesterday?
Yeah.
Let's do it. Okay, yeah, we are. So I shouldn't have asked. So at the bottom, draw your T-chart laying on its side. Right. And instead of multiplying 6 times 4 to get 24, we're going to write 6 and 4 on the T-chart. And then we're going to skip count. Now this is called LCM, least common multiple. Multiple is just a fancy word for skip count. And you already know that from long division. So let's skip count by 6s. 6, 12, 18, 24, 30, 36. Now I said you could stop after 3 multiples. And if you need more later, you can add more later. And skip count by 4s. 4, 8, 12. Now I'm looking for the smallest number they shared. 12. Circle it. So 12 will be the common denominator. Remember, you can't just multiply 6 times 4 because that's 24.
2.
So you have to think, 6 times what equals 12?
2.
And 4 times what equals 12?
3.
So we're adding 10 plus 9. Now this is more than one whole. This is an improper fraction, isn't it? So you got a couple choices. You can write a number bond. And take out one whole. What would one whole be? I'm going to pull a stick. Morgan, what would one whole be here?
12.
Right, your numerator has to match your denominator. So 12 twelfths would be one whole, right? And how many are left over, Morgan?
7 12.
So 1 and 7 twelfths. So you can draw the number bond if you want. Or, Jesus, here's the other way you have to do it. If you don't do the number bond, then I need a third, fourth set of equal signs, okay? And I want you to write 19 twelfths equals 12 twelfths plus 7 twelfths equals 1 and 7 twelfths. And I'm pretty sure Jesus already did this. He's like a step ahead of me. You don't have to do both of these. Fair enough? If the number bond helps you, use it. If you don't need it, don't use it. Okay? Fist to 5. How are we doing? All right. Let's do the lesson today. How's this different? Well, we're still subtracting. We were subtracting yesterday, though. There's a whole number. Now, it would be really cool. Are you listening? If we could just take out that whole number and then put it back in.
That's what I do.
But we can't. And I'm going to show you why. Are you ready? Don't draw this. If I just take out the whole number and then put it back in when I'm subtracting, I can do that when I add, by the way. But when I'm subtracting, I'm drawing these the same so that you can see. Can I take 1/3 minus 1/2?
No.
1/2 is bigger, isn't it?
Yeah.
Since 1/2 is bigger, I'm going to have to borrow from that whole number. What do you think I'm going to borrow? The whole thing. But I've got to change it to a fraction. So 1 and 1/3, are you with me? How many thirds is that?
4.
4. Who said 4? You're right. Look, I'm going to count. 1, 2, 3, 4 thirds. Now, would you like to know a little trick for figuring that out without drawing it? Okay, are you ready? Ryder, you're not watching. I'm going to take 1 times 3. What's that? 3. And add one more from the numerator. So what's that?
4.
And my denominator does not change. So here's your new problem I want you to write. And we'll keep practicing that strategy. Now we solve it the same as yesterday. So common denominator for 3 and 2. Let me pull a stick. Lillian? 6. Whoops, I wrote the answer by accident.
3.
So did you get 5, 6?
Yes.
Okay, that's the lesson today. Now, last year and all the other years I made them draw. And so, since I'm not making you draw, Zern's not going to make much sense to you. So, I'm going to reset everyone to lesson 8, I believe. Okay? So you won't have Zern for a few days. You won't have time today anyway because it's picture day. Okay? But tomorrow, I might have you work on some IXL. Instead, I'll find a good one with mixed numbers. Okay? All right, let's do the next one. So who remembers that little strategy I used to turn this into an improper fraction? Now, there's 2 ways I could do it. Watch the board. I could just take 5/5 plus 1/5 in my head, couldn't I? And that'll be 6/5. Or I could use that strategy they taught Mrs. Lowry and I when we were kids. 1 times 5, what's that?
5.
Plus 1 more.
6.
You might as well know that strategy in case you ever need it. Okay, so common denominator, 15. So basically, you're just checking your skills here and checking my skills to make sure I'm not making any mistakes. So the only thing that changes in lesson 6 is the whole number. That's it. Now, how many of you like the just do 5/5 plus 1/5 in your head? Then just do it, okay? If you want to try the strategy, it's more fun when the numbers are bigger. Wouldn't you say, Mrs. Lowry?
Yeah.
Okay. So problem 3, if I use the strategy 1 times 2, what is it?
2.
Plus 1 more.
3.
And did my denominator change? No. So 3/2 minus 2/3. I noticed. Yeah, every time it's just one different. One lower for the numerator, isn't it? Yeah.
3
Reciprocal.
Yes, reciprocals. Oh, yeah, they are. Skip, dot, flip. You learned the word reciprocal on Some Dog if you've been doing it. How many of you learned that word? Yeah, I didn't even have to teach it to you.
I just found out this month.
You just kind of figured it out, didn't you? Okay, let's do this one. This one will be a little more fun to use the strategy on. So 1 times 4, what is it?
4.
Plus 3. So 4 plus 3 is 7. What's my denominator? 4. You guys aren't looking up here, are you? I didn't think you needed to. I'm feeling a little lazy, so could you subtract for me? I'll pull a stick. Caitlin, did you figure out what 35 minus 16 is yet?
No.
Okay, if you need to do standard algorithm, is that okay?
Yeah.
Yeah, just do it over to the side. Okay, I need to regroup here, don't I? So, Jesus, help me out. 15 minus 6? 15 minus 6.
Oh, 15 minus 6, 9.
2 minus 1.
19.
Okay, 19/20. Do we have one more problem?
Yeah.
Okay, and then I'm going to teach you something, or we're going to do a harder one. Okay, so the strategy. I'm going to pull a stick. Jared, how do I figure out the improper fraction for this mixed number?
4 plus 9.
1 times 9 plus 4. Now, the reason you can't just do 4 plus 9 is because what if your whole number was a 2? And we'll change 1 to a 2 here in a minute and you'll see, okay? So go ahead and solve this one. Yasmin, what's 13 times 2? Very good. So 26 minus 9, Jay Lee. Have you done that yet? You can do it like this, but it's almost easier just to count backwards. So 16 minus 9. 1 minus 0. Okay, you have an empty spot at the bottom. Let's do another problem. Okay, I'll get rid of this. Let's just change this. No, I'm just going to make up a new one. So let's go with no. Do that problem. So now I have to do 2 times 5. What's that? 10 plus 3. 13 fifths minus 2/3. Solve it the same way. Ooh, this is a big number. 13 times 3, 39. So I have 39 minus 10 Uh-oh. That's an improper fraction, isn't it? So how am I going to figure this out? I can do a number bond, or I can just write it on the next row. If you'd rather just write it on the next row. Okay? I like the number bond. So if I take out one whole, Fernanda, what's it going to be?
15.
Good. And then how many are left over? Is it 14? Yeah. So my answer here is 1 whole and 14/15. Now, to me, this is a lot of stuff that we might not need to do. First, I change it to an improper fraction. Then I end up with an improper fraction and have to change it back to a mixed number. So when we get to these, Sergio, Oziel, when we get to these kind of problems, there's a better way to do it. And I'll show you that. You want to know now?
Yeah.
Turn it over to the very back. Yeah. Because if I'm going to change it to an improper fraction and then have to change it back to a mixed number, there's a better way to do it. And would you like to know what that is?
Yeah.
Just subtract 1. And I'll show you what I mean by that. So I'm going to change 2 3/5. Are you ready? So 1, I'm subtracting 1, plus 5/5 plus 3/5. So what is that going to be? 1 8/5, because I'm going to combine these two. So basically, let me write it a different way. This is a better way. I'm going to call this 1 plus 8/5. Is that the same thing as 2 3/5?
Yeah.
Yes, okay. So now I'm going to subtract 2/3. So here's your new problem. 1 8/5. Write this down. Minus 2/3 equals. Now, here's the problem with this. I'm going to take this 1 out, and I'm going to put it back in my answer. Okay? Because I don't want to use it. I already changed this to an improper fraction. So I'm going to take the 1 out, and I'm going to put it back in my answer. Where's my answer? All the way down here. So that's a whole number of 1 I just wrote. Everybody write it. What's my common denominator? 15. So if you're going to do it this way and take the 1 out and put it back in, you might want to write it from the very beginning so you don't forget. Okay? Now you just solve it the regular way. So the only difference here is I just took 1 out instead of using both whole numbers. So 8/5, 2/3. Do you guys remember what the answer was? Okay. Oops. Was it easier to just take 1 away from the 2 and borrow 1 whole to make this 8/5? It was. So when we get to these kind of problems, that's how we'll do it. This is just a little snippet of a preview for you. All right? Good job today.